Good afternoon to everybody. So we are discussing stacks. We already know, we are already covered what is stack, what are the operations and everything. So stacks are, we know that stacks is a last in first out list. What is last in first out? An element which is inserted at last will be deleted at first. That we called as stacks. An element which is inserted at last will be deleted at first. Such a list we called as stacks. In stacks, all insertions and deletions will be done at one end called as top. We are always insert elements at the top and we are always deleting elements from the top. Such a list we called as a stacks. In stacks, we are performing different operations: push, pop, display is, full is, empty display. Like this, we have different operations. Push is used to insert an element into the stack. For each element insertion, the stack is the top is incremented by one. For each pop is used to delete an element from the stack. For each element deletion, the top is decremented by one. So when push, it will be incremented by one. With the pop, it will be decremented by one. The stack is empty, so when there is no elements, then the stack is empty. So we have similarly we have is full, is empty. So these operations are implemented by using either arrays or linked lists. So we can implement the operations of the stack such as push, pop, is, full, is, empty, display, everything. So these operations we are implemented by using arrays and by using linked lists. In last class we are discussed implementation of stacks by using arrays. And today we discuss stacks by using linked lists. How to implement stacks using linked lists. So stacks using linked list. We can implement stacks using arrays and we can use. So the different operations that are performed on stacks is we discuss push, pop, display. We discuss only these three modules. These three are enough. That's it. Push, pop, and a display. So what is push? This function is used to insert an element into the stack. In stacks, all insertions will be done at front. So instead of top, I will do front or top. So all insertions will be done at the top. So how we can insert an element? Suppose, so this is my list, I think. So we are discussing implementation using linked list, that's right. Suppose this is my list. This is first node. Page. We have one more node. This is another node. There is element. Suppose we want to insert an element. Suppose 10. Suppose I want to insert 10. So 10. Suppose here I want to insert 20. So this is, let us assume that this is the stack. Suppose this is, we know that this is the stack. We called as start. So this is stack. Suppose I want to insert a node. This is already, we have the stack. I want to push. I want to push 30 into the stack. Suppose already we have 10 and 20. I want to insert 30 also into the stack. How we can insert? So when the new element is inserted, always the new element is at the top of the stack. Then, 20. So this is already. So this is a stack after insertion. So where we are inserting the element, we are inserting the element at front. So when we this that we call as push. Push means insertion of an element at front. How we can insert an element into the front? So we know the function insert front module. Then it will be same as push. Suppose I want to insert an element at front, we call it push. So how to insert an element into the linked list? What is the procedure? So what is the procedure we are using to insert an element into the stack? So how to we can insert? First of all, you have to allocate storage. How we can allocate storage by using the function temp equal to new node. So when you write the method temp equal to new node, the system will allocate the storage. After allocation, then we can enter the value. After allocation, we can enter the value. Then, if start equal to, we call this start, we give start equal to null. So indicates that there is no stack. Then it is start equal to 10. So and we can also call this else current dot next equal to 10. Again we go for current equal to 10. This is the method we use. So exclusively when suppose you want to write some more exclusively, if start equal to null, start equal to temp. So if start equal to null, start equal to temp, then we can temp dot next equal to null, current equal to current dot next equal to temp, current equal to temp. This is the procedure we are using to insert an element into the stack. This is the module. We can implement by using arrays or by using linked lists. So this is the implementation of stacks by using arrays. Suppose I want to insert an element at front, we can use function start. So if we exclusively want to write stack colon push. So if temp, first of all you have to allocate the storage, then enter the value. If start equal to null, you make it as a start equal to temp, temp dot next equal to null. So else current dot next equal to temp. You make it as current equal to temp. This is the way to insert. Instead of writing this, I'll use and I will remove this. One line will be reduced. So if start equal to null, you make it as a start and temp dot next equal to null. Otherwise, make it as current dot next equal to null temp. Otherwise, wrong. Temp dot next equal to start, not correct. Temp dot next equal to start. It's enough. No need to current. No need of current. If start equal to null, if start equal to temp, start temp dot next equal to null. Else, so temp dot next equal to start and so ఎవరికి రా మళ్ళా మెంటల్ వచ్చినట్టుందిరా? అరే మీ నెంబర్స్ అన్ని నాకు ఇక్కడ పడతా ఉంటాయి. మీ నెంబర్స్ నోట్ చేసుకుంటాను. ఇంకా చెప్పను. మీ నెంబర్స్ నోట్ చేసుకొని రేపు కాలేజ్కి వచ్చిన తర్వాత మిమ్మల్ని ఎలా చేయాలో అలా చేస్తాను. మీ నెంబర్లు పడతా ఉంటాయి ఇక్కడ ప్రతిసారి నాకు. ఎవరు ఏ అదవ పని చేస్తున్నా ఆల్రెడీ ఒకసారి మీకు చెప్పా చాలాసార్లు. ఇంకా మళ్ళీ మీరు ఇదే చేస్తున్నారు అనుకోండి, మీ నెంబర్లు నాకు ఇక్కడ డిస్ప్లే అవుతూ ఉంటాయి. రాయొద్దురా అని చెప్తా ఉన్నా, మెంటల్ పడతా ఉంది మీకు. మెంటలారా మీ అందరికి క్లాసులు ఎందుకురా రావటం? మీరు గాడిదలు కాయకూడదు. మీ ఇళ్ళల్లో ఇంట్లో బర్రెలు ఉంటాయి కదా, బర్రెలు కాసుకోవచ్చు కదా. పోవటం పోక ఏదో పనులన్నీ ఎందుకు ఇక్కడ? చెప్తే ఇంకోటి నేను లాగిన్ అవ్వలేదు సార్, ఇంకోటి లాగిన్ అయ్యారని అదో అబద్ధాలు చెప్తుంటారు. ఇది ఒక ఎదవ పని ఉంది మీ క్లాస్. మీకేం చెప్పాలా ఈ క్లాస్కి? గాడిదలు కాయటం కంటే బెటర్ మీరు ఉడతలు బట్టిన వెళ్ళారు. ఎందుకురా మీరు? So push function is used to insert an element into the stack. So we are always insert an element at front. So first of all, in order to insert an element, first of all you have to allocate storage, then enter the number. If start equal to null, you make it as a start and temp dot next equal to null. Otherwise, you make it as temp dot next equal to start and make the start equal to temp. This is the process we are using to insert an element into the stack. So we can reduce the module also instead of writing number of lines. We can reduce the code also. If start equal to null, temp dot next equal to null. Otherwise, then temp dot next equal to null, then start equal to temp. Else temp dot next equal to start. It's enough. So very simple work. So this is called as push. Another we have the pop. This module is used now 549 ఏంటి చెయ్యి ప్రాబ్లం ఏంటి? ఎనీ డౌట్? 549 is there any doubt? Why you raised hand? మీ నెంబర్స్ అన్ని నోట్ చేస్తున్నానమ్మా అందరూ వరుసగా మీ క్లాసులో చేసి అదో పనులని. Why you raised hand? ఇవన్నీ ఒకటి నేను కాదు, నాకు నెంబర్ పడతా ఉంటుంది. నేను కాదంటే ఇంకెందుకు మీరు క్లాసు? అబద్ధాలు చెప్పుకోవడానికి సరిపోతున్నారు. సో టూ బ్యాడ్. ఈ నెంబర్ పడితే నేను కాదంటే నేను అప్రూవ్ చేసేటప్పుడు మొక్కలు చూసి అప్రూవ్ చేశాను. ఇంకా క్లాసులు కూడా ఆఫ్ చేయాలి మీ అందరినీ. నేను మొక్కలు చూసే కదా మిమ్మల్ని అప్రూవ్ చేసింది. అయినా కానీ ఇంకా మీరు so can you switch on your video? I will see. So you are not raised hand. Okay. Don't repeat the things. It's time for me to take the class, not for to give the class for this type. This module is used to delete a number from the stack. So to delete a number from the stack, we use this module. So this module is used to delete an element from the stack. So in stacks, all deletions will be done at front. For each deletion, the stack is empty when front start equal to null. So this is the module topper. So pop module is used to delete a number from the stack. Suppose I want to delete a number from the stack, we use this module. The stack in stack, all deletions will be done at front. So we are performing the operations at front. The stack is empty when start is null. When start equal to null, then the stack is empty. So we go for one example. Suppose this is already we have the stack. Suppose we have the elements 30, 10, 20. We have the stack. Suppose this is my stack. So this is stack. So when we are deleted, after pop, After pop, then the stack is. So this is the function we are using. So after pop, so when always we are always delete elements from the top. So when deleted, then the top is decremented by one. This we call as pop. That means insert begin and delete begin modules we called as push and pop. Push and pop we called as insert delete and delete. Insert delete and insert begin. So pop module is used to delete an element from the stack. So the stack is empty. So if start is equal to null, cout, the stack is empty. When top equal to null, then the stack is empty. Otherwise, we can delete the element. When top equal to null, then the stack is empty. Otherwise, we can delete the element. So we can delete element. So when you deleted the current equal to start equal to current dot next, delete current is the module. So we make it as current first node, then we may change the start, then delete node. This is the process we are used to delete an element from the stack. So this is called as a stack. Then we go for display. This function is used to print the elements of the list. We can print the elements of the list. So void stack display. If start equal to null, say stack is empty. Stack equal to null, then stack is empty. Otherwise, we can print the elements from which position? From first position, current equal to start. We can print the elements from first position. That's why current equal to start. While current not equal to null, cout current arrow number, current equal to current dot next. So this is the process we are using to print the display. These are the modules we are using to print the elements of the stack. Stack, what is stack? What are the operations we are performed on stacks? A stack is a last in first out list. Last in first out means the element which is inserted at last will be deleted at first. So in stacks, all deletions will be done at front. Similarly, deletion pop, we call as pop. In pop, all deletions will be done at front. The stack is empty when start equal to null. So like this, we can insert and delete the elements from the stack. So then we go for implementation, how to implement stacks using go for implementation by using linked list. How to implement the stacks using linked list. Suppose I want to implement the stacks using linked list. We require header file iostream.h hash include conio.h class node. First of all, you have to declare the node. Int number node star class stack node star 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 comma star temp comma star current public stack start equal to null. So initially we make it null. Then uh, we have the functions void push, void pop, void display. These are the three functions we are implementing in stacks. Push, pop, and display. These are the three functions we are using to insert the value. So first we implement void stack push. This module is used to insert an element into the stack. So how to insert the element into the stack? First of all, you have to enter the value. So temp equal to new node. This is the module. First you have to allocate the storage. Then enter value. If start equal to null, temp arrow next equal to null. Else is to make it as a temp dot next. Start equal to 10. This is the module we are using. This is called as push. Push module is used to insert an element into the stack. In stacks, we are inserting elements at different. That's why, first of all, you have to allocate the storage, then enter the number. So after entering the number, you will check whether already list is there or not. If the list is not there, if start equal to null, then temp dot next equal to null, else temp dot next equal to start and start equal to temp. Similarly, we have the pop void stack pop. If start equal to null, see out stack is empty. If start equal to null, then the stack is empty. Else we can delete. When we delete, current equal to start equal to current dot next, delete current. So this. So this that suppose we want to delete delete it. That's enough. Display. Void display. Void stack colon display. If start equal to null, cout stack is empty and else for current equal to start, current not equal to null, current equal to current arrow next, cout current arrow number. So this is called as display. So we will print the element from the start. That's why current equal start, while current not equal to null, current equal to current dot next. We print the number current equal current cout current arrow number. Then so we automatically move to next one. So these are the three functions we are implementing. What are them? Push, pop, and display. Push function is used to insert a value into the stack. Pop is used to delete. Push is equivalent to insert begin. Pop is equivalent to delete begin. If you know the single linked list, then it will be very easy. Already told. So a single linked list is very important. Once you know the single linked list, so you can know each and everything. Single, double, circular, stacks, queues, everything will be so from those modules. That's why student must know the single linked list. So the push up operation, which is same as insert begin. Pop is same as delete begin. So just the name of the function is changed. So the operation is same. So we have also, our display is also so. That's why when you know the insert begin, delete begin, the display, then you know the stacks. That's enough. Void main. So one push, two pop. Display. 4. Exit. See. Enter your choice. See. Switch. Here's one. Push. So you just call object dot s dot push. Then break. Case 2. S dot pop. S dot display. So this is the program. So this minimum, these are the minimum programs we call as complete very big programs, data structures. Some modules. Oh, number and next. Actually, these must be declared in public session, because if it is by default, it is a private. That's right. Statement missing semicolon. Yes. One more is there, while ch not equal to 4. Yes. So this is the program. 1 push, 2 pop, 3 and 3 display, 4 is exit. Suppose I want to insert element 1. Enter your number 10. Suppose I want to insert one more. Enter number 20. 3. 1. Enter number 20. 1. I will change some small work is required. I will change it. I will write S dot display also, so that you will get S dot display. Push 1. Enter number. So the stack is 10. 1. 20. Then the stack is 20, 10. Yes. Suppose one more. 1. 30. Then the stack is 30, 20, 10. Suppose one more. 40, 30, 20, 10. So like this, we are always inserting the elements at front. So this is called as push. Suppose I want to delete element 2. So deleted element is 40. So then the stack is 30, 20, 10. So deleted element is 40. So 40 is deleted. Suppose you want write, you can write it also. Deleted is 40 and the stack is 30, 20, 10. Suppose you want to delete one more, 2. Delete stack is 20, 10. Suppose you want to delete one more. Suppose you want one more. Then the stack is empty. There are no elements. That's why you cannot delete. So suppose 3. Stack is empty. 4. So we can exit. You can write also code here, some one line. The deleted number is CURR number. One. Then the stack is 10. 1. Then the stack is 20. 1. 30, 20, 10. 1. 40, 40, 30, 20, 10. Suppose 2. The deleted number is 40. Then the stack is 30, 20, 10. Suppose one more. The deleted number is 30. Then the stack is 30, 20. So like this we can use. So if there is no elements, the deleted number, if cannot delete any number, then the stack is 20, 10. Suppose we want one more. Push pop. So we want one more. So we can use. The deleted number is this. So like this, we can delete the numbers. So suppose we want to exit 4. So this is the way we are using to implementation of the stacks using linked list. So like this, we have the stacks. Stack is a last in, first out list. The element which is inserted at last will be deleted at first. In stacks, all insertions and deletions will be done at one and called as top. So for each element deletion, the top is incremented by 1. For each element deletion, the top is decremented by 1. So what are the applications where these are used? So suppose you want to implement recursive functions, we use stacks. You have to evaluate an expressions, we use stacks. How to convert infix to postfix, use need of stacks. To give DFS graph ourselves, we need stacks. These are the different applications of stacks. What are the operations? Actually, we have the push and pop. Push means to insert an element into the stack. Pop means to delete an element from the stack. For each element insertion, the top is incremented by 1. For each element deletion, the top is decremented by 1. Forward display means we print the elements. Actually, these are the main 3 modules. Remaining are the optional. Is full, is empty, which is also covers in the modules. So no need to write explicitly actually. So after that, we can implement these operations using arrays as well as linked lists. So we are already covered using how to implement by using arrays. Today's class is how to implement using linked lists. This is about stack operations. What is a stack? What are the operations that are performed on stacks? This is about today's class. Okay, bye.